The topic we are going to be seeing today is nuclear reactors. This is the image or the picture of nuclear power plants. Nuclear reactors. A nuclear reactor is a device in which the nuclear fission reaction takes place in a self-sustained and controlled manner. Reactors can be classified into research reactors, production reactors, and power reactors. So, reactors are of three classifications. One is research reactors, the second is production reactors, and the third is the power reactors. The purpose of research reactors: it supplies neutrons and produces radioisotopes. The purpose of the production reactors are: it converts non-fissile materials to fissile materials. The purpose of the third reactor, which is the power reactors, are: it converts nuclear fission energy into electrical power. So the nuclear reactor is classified into four types, which are boiling water reactor, pressurized water reactor, pressurized heavy reactor, and fast breeder reactor. So nuclear reactor consists of five main elements, which are the fissionable material called fuel, moderator, neutron reflector, cooling system, control rods, and the safety system. So these six are the main components or the elements of a nuclear reactor. So this is the representation of the nuclear reactor, which has control rods, shielding, fission chamber, fuel rods, moderator, pump, condenser, cold water, water, coolant, steam, turbine, heat exchanger, used steam, and an electric generator. So the principle of the nuclear reactor: during the fission of uranium-235, a large amount of energy is released. In a nuclear reactor, control chain reaction is produced in a fissionable material. Under steady state, the rate of energy production attains a constant level. We'll see the uses of each main elements given. The first is the fuel. The fissionable material is known as fuel. Uranium enriched with the isotope uranium-235 or plutonium-239 is used as fuel. The use of moderator. The function is to slow down highly energetic neutrons produced in the process of U-235. Heavy water, D2O, graphite, beryllium, etc. are used as moderators. The third element is the neutron reflector. The leakage of neutrons are reduced on the surface reactors by the use of the neutron reflector, and the neutron flux in the interior can be increased. Cooling system. The cooling system removes heat generated in the reactor core. Commonly used coolants are ordinary water, heavy water, and sodium. A good coolant, large specific capacity, and a high boiling point. So a good coolant has a large specific heat capacity and a high boiling point. The fifth one is the control rods. The rods are made up of boron and cadmium. They are used to control the fission rate. These rods are good observers of slow neutrons. When the rods are pushed into the reactor, the fission rate increases, and it is pulled out, the fission rate decreases. The sixth and final element is the safety system. This safety system protects the space surrounding the reactor against the nuclear flux and gamma rays present. The walls are made up of concrete and lead. So this is the presentation of power reactor. The uses of nuclear reactors. Nuclear power, the production of electric power. The second one is the production of radioisotopes. The third one is the scientific research. So nuclear reactors are used for the purpose of scientific research, in which the production of radioactive materials for the research purpose. By the use of neutrons, useful isotopes are produced artificially to study the radiation damage. Thank you.